Hi, so in this session we are going to discuss another problem, another application of bits. So that is flipping a specific bit. So flipping a specific bit means, so if you are given a number 11, you will be given another I. So n and I will be given, you have to flip ith bit. If it is 0, then change it to 1. If it is 1, then change it to 0. Only change one bit, that is ith bit. So if I represent 11, 2, let's say I want to flip this. So 11, 2 means 1 0 1 1. If you see this is my second bit. After flipping a specific bit, this should become 0 0, rest should remain unchanged, 1 1 1 1, something like this. Okay, so if I want to do this, so what we can do, I think we can do, you know that x XOR 0 is what and x XOR 1 is what. 1 XOR 0 and 0 XOR 1, 1 XOR 1, 0 XOR 0. 0 XOR 0 is 0, 1 XOR 1 is 0. 0 XOR 1 is 1, 1 XOR 0 is 1. So x XOR 0 is 1 and 0 is only x, and x XOR 1 is 0 XOR 1 is 1, 1 XOR 1 is 0. This is negation of x. We had discussed earlier as well. So if you want to flip any specific bit, you need to take XOR with 1. That bit should be 1. So if I take 11 and this is my number 0 0 0 0 1 0 1 1, I need some number which is like this bit is 1. This bit should be 1. So whatever bit will be present here, I will take XOR with this bit. So that will be flipped. So if I want a number whose ith bit is 1, so that if I take whatever is present at ith bit currently, that will be flipped. If it is 1, 1 XOR 1 will be 0. If it is 0, then that XOR will be 1. I want like this. And also I want rest of them should remain unchanged. Whatever is here should remain unchanged. And you know that x XOR 0 is x. So I want 0 at all other places like this. At all other places should be 0 and this ith bit should be 1. And we know how to get this number. You know that this number will be 2 power I. Rest all places should be 0 and ith bit should be 1. That number is actually 2 power I. 2 power I can also be represented as how? 1 left shift I. We had discussed in earlier as well. So if I want this number, I will calculate this number. I will take XOR with this. I will take XOR with this. 1 XOR 0 is 1. 1 XOR 1 is 0 is 1. 0 XOR 1 is 1. 1 0 0 0 0. So for flipping any ith bit, you want a number whose only ith bit is 1 and rest all bits are 0. That number will be 2 power I. You need to take XOR with that number and you will get that number. Okay, so if you are given a number n and you will be given a number I, so you need to hit n and n XOR 2 power I, and you know that this number will be n XOR 1 left shift I, and in z you will have the number that is whose ith bit will be flipped in number n. Okay, this is the required number. You are going to calculate that, and that is the application of XOR. Okay, we have discussed this application. It's very easy to code. You can code this, but the important concept is if you want to flip only specific bit, you need to use the XOR operator. Okay, great. Thank you.